All right. Okay, so starting with the handout with a staple in it. Okay, so working with exponents and roots. Okay? We've already had some experience with exponents in 308, but if you didn't come directly from 308, you might need a little refresher in that. We're going to have to do a brief refresher here, and I'll point out where you can go and get some extra practice as well. Some extra practice I'll give you, and some that you can find, of course, in your textbook. Using your calculator is going to help you with the number part of this, though there'll be a lot of variables involved too. So the rules that apply to variables, the calculator won't help you with. But knowing your basic calculator steps is a good backup to what we need to do. Okay? So whether you're squaring, cubing, or doing some higher exponent, the buttons are different. Okay? So this lays out what the buttons are. A square and a square root have a dedicated button. It's here, the x squared on the side, with the square root on top. Okay? Now, as you can see here, and as we're going to really emphasize and point out as we jump into the Chapter 11 material, is squaring and square rooting are inverse operations. Okay? Cubing and cube rooting are inverse operations. That means they're opposite. They reverse each other. Okay? They go together. You go in one direction or the other, you get back to where you started. Squaring can use this dedicated button. You don't have to go into any menu. So for example, 7, and then you push x squared, and then enter. Okay. Reversing the process would be the square root, which is above the x squared. You get to that with your shift key, or your second key. Mine's blue, some of them are yellow, up there in the top left. And you see it gives you an opening parenthesis. So when you put in what you want to square root, close your parenthesis, that's above the 9, and then you see the process is reversed. Now, for any higher exponent, you need to raise it to a power. It doesn't have a dedicated button. Okay? So, for example, 4 cubed is 4 raised, over here on the right, raised to the 3rd power. And some people have math script that actually shows that raised. If you're confused why yours looks different than mine, I usually show this classic view, because that's what most students have. But if yours actually shows it raised and a little blinking cursor instead of parentheses, and you're not sure how to deal with that, just let me know, and I can show you. I can show you how to switch it to classic or how to use that. Mostly, instead of closing parentheses, you'll use the arrow to arrow out of the blinker area. Okay. Here, push enter, and that's 64. To reverse the process, we need the cube root. Now, to get the cube root, there is a dedicated button, but it's in the math menu. Okay? So to cube root, you have to push math menu right there. You stay in the math menu, and you'll see it's number 4. So number 4 is the cube in front of that radical sign. You can just push number 4 or scroll down and push enter. There's an opening parenthesis. Put in what you're going to put in and close your parenthesis. Right, so the cube root of 64 takes you back to 4. Now, anything higher than a square or cube, it looks a little funny. Okay? Here I used a 5th as an example, but it's anything higher than 3. Okay? So 2 raised to the 5th power, 32. Okay? 2 times 2 times 2 times 2 times 2. Now, reversing that requires choosing an index that doesn't have a dedicated button. So the first thing you have to enter, as you see by the rules here, you have to enter the index first. And that looks yucky because, now if you've got the math script, it's going to raise it for you. But here, for most people's views, it looks yucky because it looks like a coefficient. And it's not a coefficient. It's small and raised like an exponent. It's what's called the index. But you have to put it in first. You put in, so if you want a 5th root, you put in the index first, then you go to the math button. And you'll see underneath the cube root is the x root. Okay? So you tell it the index first, which was 5, then go to math number 5. And that's not 5 times this. That means 5 stands for the x. This is the 5th root of. Notice there's no parentheses. If you and I always do this. I automatically close my parenthesis and then I get an error message. For some reason, with the nth, what we call the nth roots, the higher roots, there's no parenthesis. So you put in 32. Don't close a parenthesis. Just push enter, and it takes it back to 2. So this is just a little breakdown of the button pushes and what the screen will look like, to back you up on those. Now, the more you don't have, so you can always check if something's a perfect root, or exponent it up, or if it's a perfect root on the calculator. But that is very inefficient for your basic roots. Okay? This is a good tool when you got bigger numbers. Okay? Smaller numbers, just like knowing your multiplication tables, it's really important to sort of have these and recognize them right away. Makes you more efficient. If you use the calculator for these down here, then you're using the calculator as a crutch, not a tool. And that slows you down. Okay? So take a minute without your calculator, and without your calculator, and do these as fast as you can. Okay? Do as many as you can without the calculator backup. Now you can go then and fill in the rest with the calculator, but make a note, hey, I had to do these with the calculator, so these are ones I need to maybe make flashcards or make a list. Just look at this list. 2 minutes every night. Don't try and cram it the night before the test. It's the kind of thing that sinks into your brain, just like knowing your multiplication tables. So go as many as you can. The first 15 squares, 10 cubes, and 5/4 are good ones to have memorized.
The first 15?
Yeah, first 15 squares, the first 10. You see, the bigger the root, or the bigger the exponent, the bigger it gets really fast. Mm-hmm. Yeah. So memorizing 15 perfect fourths is just, I don't know those. Yeah. I mean, at a certain point, the calculator is a good tool, but these are ones that are still, 2-3 digits max, and the ones most commonly used. I did that really fast, just some years of just having absorbed it. Okay? And that's your goal. It won't necessarily be that fast now, but that's the idea. You want it to just be automatic. And when you see one of these numbers that I wrote in pink, you want to go, oh, yeah, that's a perfect square. Because how am I going to unsquare it now? How am I going to square root it? Because we're going the opposite direction now. You can see 1 is a perfect everything. Yeah, it always equals 1. After that, we're getting really big. Let's stop at the first 10. Recognize those first 10, you're good. Really common ones for fourth roots. Fifth roots, you can even make a list of fifth roots, the first 5 fifth roots. Or even less than that, because that gets really big then. Yeah. The more you recognize, the better it is. But at least these. Okay. So I'm going to remove this and move forward. You can always go back and fill it in yourself later. If any of them that you were slow on, use your calculator, fill it out, and then find some, 2 minutes a night, look at it. Make little flashcards, whatever it takes. It's like knowing your multiplication facts. Okay. I'm also going to scan this in and all, but you can fill this in yourself with your calculator as a backup as you need to, and practice the ones that you're sketchy on. Okay, so before we jump into radicals now, we're going to look at a little further with exponents and look at our basic rules. Okay, so there's the non-stapled handout on one side. There's a lot of exponent rules, positive and negative exponents, etc. All putting that together. We're just working with positive exponents right now. And there are rules that build on each other, and more complex problems we use multiple rules, but it all comes down to these 3 basic rules, the big 3. Okay? Product, quotient, and power. Okay? So you want to be really solid on what these tell you to do, because we're going to be reversing this process with radicals in chapter 11. So product means what? What operation? Right. And quotient means divide, right. Product is the answer to a multiplication problem, and quotient is an answer to a division problem. So when we're talking about the product or the quotient rule, we're talking about either multiplying or dividing. Notice I did not write add or subtract. Okay? These are problems where you are multiplying 2 things or you're dividing 2 things. The rules for addition and subtraction are different than the rules for multiplying and dividing. Okay? Our exponent rules apply to multiplying and dividing. Now, power, what does that deal with? When we're talking about a power rule, we're dealing with exponents, right, yeah. So that is an operation too, but it's an operation that's related to multiplication, because all you're doing is repeat, all exponents are repeated multiplication. You're multiplying something times itself multiple times. Okay. Now, if you, I'm just going to take a note here, when I say if I have is the next line, I want you to tell me, got x to the 4th times y squared, or if we have x to the fourth times x squared. Can we apply our product rule to this problem?
No.
Why not? The bases are different, right. Can we apply our product rule to this problem?
Yes.
Because we have like bases. Now we don't need like terms. Remember, like terms are a bigger category. Like terms means same base, same exponent. You must have the exact same thing in order to add or subtract. Adding and subtracting requires like terms, same base, same exponent. Of course, not required for the product and quotient rules. You just have to have like bases. Of course, the exponents are going to be different, or they may be different, because the product and quotient rules tells you what to do with the exponents. But you can't do these things with the exponents unless you have like bases. Okay? So if you have like bases, absolutely required. So of course this can't do anything with this one. Now we can take the dot away and write it as x fourth y squared. That means multiplication. We just can't smoosh the exponents together. This would become what? Right, adding the exponents, exactly. Okay. So if you have those like bases, the quotient rule says, the product rule says, add the exponents. This is not the addition rule. This is about multiplying two things. The rule is if you are multiplying two things with like bases, then you add the exponents, because this tells you the total number of x's you have. X times x times x times x times x times x. Means you have a total of x's used as a factor 6 times. So the total number of times means if we add up 4 x's here and 2 here, that's the total times it's used as a factor, which is a multiplication word. Now, what do you do when you have like bases and you're dividing?
Subtract.
Right. Because it's like we're canceling out. We have some number of x's on top and some on the bottom, and we're basically canceling out, which is, for our purposes, means we're subtracting. If there's 4 on top and 1 on the bottom, we do 4 minus 1. So we have 3, because we're canceling out one of them. So to subtract, I'm just going to abbreviate there, subtract the exponents. Okay. Now, with this, it's not a matter of having, with the power rule, it's not a matter of having like bases. This is about a base raised to a power that is then raised to another power. So it's one base, it's just got it to a power raised to another. So it's not a matter of like bases, because you're just working with a single base. In the basic rule, at least. So base raised to a power raised to another power. Okay. And so in this case, when you've got a base with a power raised to another power, say we've got x to the 4th squared, what do we do to the exponents? Multiply them, right. Multiply the exponents. And remember that the power rule is really, dealing with exponents is just another way, it's a form of multiplication. It's multiplying something times itself. It's repeated multiplication. So all this means is x to the 4th is used as a factor twice. Okay. Just like 3 squared means 3 times 3, x to the 4th squared means x to the 4th times x to the 4th. And then we have a product rule which says we do what to the exponents? Product rule says add them, which gives us x to the 8th. But we can get there in a shorter form by saying x to the 4th 2 times, which is x to the 4 times 2, which is the same thing. Times 2 is the same thing as adding something to itself. Okay? So either way, you get the same thing. The power rule is just a shorthand way of doing the product rule. Okay? So multiply the exponents. So algebraically, definition-wise, we write this as a to the m times a to the n, showing with the a that we have like bases. That's assumed when we use the same letter for the base. And we keep that base. That base doesn't change. And we just add the exponents. That base is a factor that many times now, a total of that many times. And if we have a base divided by a like base, then we are canceling out anything that matches, basically. So by canceling, we mean we are subtracting. So we have that base with the m canceling out, minus n. And algebraically, we have a base raised to a power, raised to another power, which means we have that same base, but this means we're using a to the m as a factor n times, so m times n. All the other exponent rules build on this. So some basic examples, and then for our purposes, reversing the examples, because we're going to go in the opposite direction today. A basic example would be x to the 5th times x cubed. Well, what would we do to the exponents?
Add them.
Like bases, product. Always, if this were a plus sign, could we add these? No. This is the product rule. It requires multiplication. Adding them would not be possible because these are unlike terms. Terms for addition must have same base and same exponent. Unlike terms, it's like apples and oranges. You still have apples and oranges. You can't add them. We're not making a smoothie. Okay? Not smushing it together. But for multiplication, we can smush them all together. We have 5 total as a factor here, 3 total as a factor there, for a total of 8 x's. X is a factor 8 times. Because everything here is multiplication. This is x times 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 x. So it's x times itself 8 times. Right? So if we had x to the 7th divided by x to the 4th, that is equal to x to the
Third.
right. 7 canceling out 4 minus 4, giving us x cubed. And if we had x squared raised to the 8th power, that means x squared is a base 8 times. X squared times x squared times x squared, and so on, 8 times. Right. So that's x to the square times 8. X squared 8 times, or x to the 16th. Okay. Not x to the 10th. Now, we're going to be taking those same rules and reversing the process, because working with radicals in Chapter 11 is an inverse operation, an opposite operation to exponents. So let's say we started with x to the 12th. Okay. Now, let's say we wanted to break that up into 2 x's. All this means is x times x times x times x times x, say that 12 times. So instead of saying it 12 times, we could say it twice with a multiplication sign. What if I said x times itself 10 times, then what would this have to be?
2.
2, right. So reversing our product rule says that this would be x to the 10th times x squared. Or you could also do x to the 9th times x cubed. You could do x to the 1 times x 11, x to the 11th. Any combination of that adds up to 12. So we're reversing it, we're breaking it down. This is like factoring a number. If I say, here's the number 15, break it into factors, well, I could write 1 times 15, or I could write 3 times 5. Okay? This is just factoring an exponent using the power rule in reverse, product rule in reverse. Okay? Now we can reverse the quotient rule too. This is not really going to, isn't going to apply to what we're doing now, but it's the same idea. If we had x to the 6th, and I said write that as x to the 9th over something, then what would that something have to be?
33.
Right. In order for that to be true, we'd have x to the 9th over x cubed. You can fill in that blank. And anything that subtracts to make 6. So it could be 8 and 2. It could be 6 and 0. Anything that subtracts to make 6. So the product rule we're going to use a lot in reverse, and also the power rule we're going to use a lot in reverse. So let's say we start with x to the 14th, and I say, okay, we're going to have this x here, and I want you to make it something squared. So what do you have to put there in order for this to still have the value of x to the 14th?
7.
Right. This would be x to the 7th squared. Still x to the 14th. So if we want to turn any power into a square, we're basically breaking that in half. We're dividing by 2. Because the opposite of multiplying exponents is dividing exponents. So the power rule says multiply the exponents. If we want to turn it into a square, we just divide by 2 and we get 7. We're reversing multiplication with division. Here we're reversing addition with subtraction. 12 minus 10 is 2. 14 divided by 2 is 7. Okay? Now on the back, we're not going to do this right now, but if you have, especially if you have any struggle with the exponent rules, it's not a recent thing, you need to practice them. I did point out, this is 5.1 and 5.5, which were 308 chapters, but you have access to all of it. It's the same textbook. It's all in your ebook, okay? As well as the study plan and all the other resources on my math lab. So I suggest, think of this like homework. It's not homework I'm going to pick up and grade. But before I see you on Tuesday, this is a real good exercise to look through. These are 5 problems, exponent problems, and all of them are wrong. Okay? All of them are wrong. Your job is to try and find the mistake. You want to find out what mistake was made, what should you have done instead, and then write what the correct answer is. Okay? So take a look over those. I'm going to leave this aside for right now. At the beginning of the next class, we'll sort of go over some of these. Okay? And I'll also then scan in and post all the solutions. So like I said, treat it like homework, not something I'm going to pick up, but especially to really buffer your exponent skills. The other very important part of this as well here is, because this is going to become very important next week, is we're going to focus on simplifying and multiplication and division today. Next week we're going to be moving into addition and subtraction. And the rules for multiplication and division versus addition and subtraction are always different in lots of areas of math. So it's very important to recognize that you're dealing with addition here and multiplication here. And even though we have these terms that look the same, whether you add them or multiply them makes completely different answers. Okay? What must you have to add? What must you have to multiply? Okay? So it says if you have, and then what you do. So go ahead and look at that too. And we're definitely going to, at the beginning of next class, sort of go over some of these mistakes, and as well as transition into what are our addition rules. Okay? So yeah, so make sure you keep this, look over it, try and fill some of these out before I see you on Tuesday. Okay? I'm going to set it aside for now and come back to the second page of your chapter 11. So we'll jump right into chapter 11 now. Okay. Okay. All right, so chapter 11, it's all about roots, square roots, cube roots, and higher roots, what we refer to as nth roots, n meaning any number, okay? Any number higher than 2 or 3, nth roots. As already sort of pointed out, exponents and roots, what we're looking at in sort of our little exponent review there, is that exponent and roots are what's called inverse operations. They're opposites. They reverse each other. Okay? So what will we have to square in order to get 36? 6. Okay. Now there's another thing we could square and also get 36. What else can be squared to get an answer of 36? Negative 6, right. Now how will you write that?
A negative outside parentheses or something.
With negative inside the little house.
Outside the parentheses.
Inside or outside the parentheses?
Outside.
Inside. It's inside.
A rousing debate.
Outside, it's non-real numbers.
You're thinking about with the under the radical sign, but just thinking of exponents.
Oh, okay.
Yeah. So do we need parentheses here for this to be positive? No? Remember the 2, the exponent, the square in this case, is only attached. It only affects 2. It's like a magnet. It only affects what it's touching. So if I write negative 6 like that, what is that 2 touching? Only the 6. That means the negative is not affected by the 2.
So it's
This would be 6 times 6, which is 36, but then times, and would I get a positive 36?
no.
Base matters in exponents. The exponent only belongs to whatever it's touching. So if you wanted to touch this entire thing, you must put parentheses around it. Okay? The base is only what's touching. The 6 is touching that. Not a problem if your base is positive. If your base is, this means 6 times 6. Okay? This means 6 times 6. This right here means negative 6 times negative 6. Right? And what is a negative times a negative? Yeah. Positive times positive is positive. Negative times negative is positive. Okay? So this means this is a factor twice, 6 times 6. This is a factor twice, negative 6 times negative 6. Either way, you get a positive answer. So consider this then. What if I did write negative 6 squared? What does that equal?
Negative 36.
Right, because what this means is negative 1 times 6 times 6. The square only affected the 6. Okay? A negative sign is often like just write negative 1 times. And with exponents, that's absolutely, you normally don't have to think of a negative that way. We think of the negative as belonging to the number. But with exponents, it's all a separate thing. We can write it separately as a negative 1, and then this is 6 squared, which gives us negative 36. And you can back this up in your calculator as well. 6 squared is 36. Parenthesis negative 6 squared is also positive 36. But if you just put in negative 6 squared, negative 36. Okay. Very important distinction. Okay. Now reversing the process, we're thinking this is we can do a square root of this if it has basically twin factors, matching factors, because that's all exponents are, is multiplying something times itself. So this has twin factors of 6. So this also has twin factors of 6, but a minus. So the answer to this would be negative 6. This is important because a square root, we're going to assume, basically there's two ways to get 36. We can get 36 by doing positive 6 times positive 6, or we can get 36 by doing negative 6 times negative 6. If we just write it like this, though, so there's two ways to get that 36. But if we just write it like this, we always assume that we want the positive answer. Okay? That's the go-to. That's the default, the assumption. We assume this is what's called the principal square root. Okay? Principal, also known as the positive square root. And principal meaning that's our go-to, that's our default, that's what we assume. Okay? If we want the other answer, the other possibility, if we want the negative square root, then we have to put a negative, not underneath, that changes everything, we'll see why, but in front. Okay? So this with a negative in front means that you are being told specifically that you want the negative square root, in which case the answer would be negative 6, the other possibility for your base, but you only use that if you were told to with the negative in front. Otherwise, we assume we're working with principal square roots. Positive answer. All right, so reinforcing a little vocabulary. This, of course, when dealing with exponents, is called the base, and that is the power, or the exponent. Now we're working with the opposite, the inverse operation of radicals. That right there, it's a little raised number in front of the radical sign, is called the index. What's underneath the radical sign is called the radicand. I'll be using that word a lot. Make sure you're very comfortable with understanding a radicand is what's under the radical sign. And then that's the other one right there. That is the radical sign. Sometimes I just refer to as the radical or the radical sign. The radicand is the thing that's underneath it. Now when we get into product and quotient rules of radicals, we'll see that what we're allowed to do is opposite what we're allowed to do in the exponent rules. We have to have like bases when we do exponent, when we use our exponent rules. We have to have like indices, that's plural of index, when we do radical, product rule for radicals. Just planting the seed. We're going to come to that by the end of class. Okay, so here's the basic algebraic rule for what a radical means. If the square root of A is equal to B, if and only if B squared equals A. Like, your eyes start to cross a little bit. Okay? Look at this in terms of numbers, and it becomes a little more clear. Let's